Given a function, right away, we know that the fundamental theorem of algebra tells me how many roots based on the degree. What is the degree of this function? Degree is just the highest exponent.
Yeah, 3.
So we know there are 3 possible roots. That's an odd or an even number?
Odd.
It's an odd number. So I asked that because odd tells me that if the degree, all of this is based on the degree of the function. The degree tells me how many roots. The degree tells me the shape, because if it's an odd number, then that tells me that the 2 ends are going to point in different directions. One end is going to go up and one end is going to go down, whereas if it were an even number, the ends would point in the same direction. And then the other part is the actual direction. The leading coefficient, is the leading coefficient positive or negative? The leading coefficient is your A value 2. So A is positive, greater than 0. So that tells me which side points up, left or right.
Right?
The right side. The normal right side is going to point up when A is positive. And if we know which side, what the right side is doing, and we know the shape based on the even or odd degree, then that will tell us what the left side is doing, right? Does that make sense?
Yeah.
So we know that it points in different directions. The right side points up, which means the left side is going to have to point down. And it crosses the x-axis or has 3 possible roots. Those roots could be real or complex. Now, synthetic division would help me determine what my roots are. So like if I were asked a question like, is x minus 3, is this a factor? Is x minus 3 a factor of this function? We could use synthetic division to see, right?
Mm-hmm.
All right, so we start with setting up our box on the outside that represents the 0, and the 0 is what we get when we set x minus 3 equal to 0. So if x minus 3 equals 0, then x equals what?
Positive 3.
Positive 3. So that's what I'm going to put inside the box out here. That's what I'm dividing by. And then I'm going to use the coefficients. The one thing we have to remember is make sure those coefficients go in descending order. We don't skip exponents. If we did, we would have to fill in a 0 for the missing coefficient. But I don't see where we skipped anything because we go down from the 3rd power to the 2nd power to the 1st power to no power. So we didn't skip any exponents. It's in descending order. My coefficients are 2, 3, -2, and -3. And that tells me what I'm going to put as what I'm dividing that 3 into when we're doing the synthetic division. I list those coefficients. I'm going to draw a line and bring down the first coefficient to get me started.
Mm-hmm.
And then I multiply. 3 times 2 is?
6.
So when I'm going this way, I'm going to multiply. 3 times 2 is 6. Put that in this next row, and when I'm going down, I'm going to add.
Mm-hmm.
So 3 plus 6 is?
9.
9. Then I'm going to do it all again. Multiply. 3 times 9 is 27. And then I'm going to go down and I'm going to add. -2 plus 27 is positive 25. Go this way and multiply. 3 times 25 is 75. Go down and add. -3 plus 75 is 72. Is this a factor? Based on synthetic division, it's only a factor if we get an answer here in this last part, a remainder of 0. Did we get that? No. So we would say no, x minus 3 is not a factor. We could try another one, like x minus 1. If we were going to set that up with synthetic division, inside the box, I set x minus 1 equal to 0 and solve. So that's going to tell me that x equals 1 would be where it crosses the x-axis. That's the value of the 0. So does 1 divide evenly into this with a remainder of 0 using those same coefficients? Bring down the first term and multiply. And we get
2.
And then we're going to
add it to 3. That's 5.
Okay.
And then
here?
multiply the 5, 5, 1. So we're just going to put 5. 3. 3. And then that's 0.
Oh, look. Yay. That one worked. It gave me a 0 at the end, which tells me x minus 1 is indeed a factor. And these coefficients that are left right here, let's go backwards. Let's go backwards and say, okay, well, this is what's left. Drop the degree because you factored out one factor of x, so it's not a cubic anymore, it's a quadratic, and use 2, 5, and 3 as the coefficients of x squared, x, and no x. So I'm going to fill in the coefficients 2x squared plus 5x plus 3. And there's my depressed equation. It's a depressed equation because you've removed one factor and made the exponent go from a cubic down to a quadratic. So now we've got it in factored form partially, right? We would have to stop and ask, if we were trying to factor it further, could that quadratic be factored? What two numbers multiply to give A times C and add to give B? We could even do that now. What two numbers multiply to give A times C? What is A times C? Here's my...
C. Wait, is the C 5?
My B value is 5.
Okay.
My C value is 3.
3. 6.
So then that's my product. What two numbers multiply to give a product of 6, but then give me a sum of B. And B is 5. So what two numbers multiply to give A times C and add to give B? What would we get there?
3 and 2.
3 and 2. Now you can stop and do factor by grouping, or you can do the strategy where you divide out the A from both of those. If I was going to divide out the A from both of those, A is 2. 3 is not divisible by 2, but 2 is divisible by 2. What do I get when I divide 2 by 2? 1. So that tells me my factored form is an x plus 1 for the 1 and a 2x plus 3. Because 3 is not divisible by 2, so 2 becomes the A value. 2 becomes up the leading coefficient there in that binomial. And if you go back and think about multiplying it out, 2x squared plus 3x plus 2x.
I'm sorry, did you ask me a question?
No.
Oh.
Plus 3. If we were to multiply those two binomials, it would get me back to where I started. So there, we've even got it in just by knowing the first, finding out the first factor and using synthetic division and writing the depressed equation, we were able to factor that quadratic and get the cubic in its final factored form, leading me to what zeros? What do we now know are the zeros of the function?
X minus 1, x plus 1, and 2x plus 3.
Those are the factors. To take that and find the x-intercepts, set each factor equal to 0 and solve. And my x-intercepts are?
Wait, I'm confused.
Like if you've got it in factored form, once you have it in factored form, set each factor equal to 0.
Oh.
And solve for x to find your x-intercepts. What is x when y is 0? Because that's what we're finding, right? We're going to put a 0 in place of f of x, which is just another way to write y, and apply the zero product property, which says that if I have it in factored form, I can just set each factor equal to 0 and solve for x. What would I get when I do that?
The first one would be positive 1.
Good.
And then the second one would be negative 1. And minus 2 divided by 2. Negative 3 over 2. Will we simplify that more, or?
Either way. Negative 3 over 2, negative 1.5, however you think of it best, or however it makes sense to you, or whatever you see as an option on an answer choice is fine, as long as it's equivalent. Those would be where it crosses the x-axis. Now, knowing what we talked about already with end behavior and applying those x-intercepts, negative 1, negative 1.5, and 1. Negative 1, negative 1.5, and 1. I'm just doing a real quick sketch. I could also plot the y-intercept. What's the y-intercept?
Negative 3.
Good. Always easily found from standard form when x, just by plugging in 0. So negative 3 is my y-intercept. So now, just knowing the end behavior, I know it's going to have to start from down here. When we go from left to right, it's going to start from the bottom, go up through that first x-intercept of negative 1.5, turn, go back down through the next intercept of negative 1, cross over the y-intercept, and go back up through the last intercept of positive 1, and then continue going up in that direction. Like, see how we can connect those things now? We've got in behavior, we start knowing that, and then we've got a process for finding intercepts, and now we can sketch the graph and understand the shape and the idea of the graph just by hand, really.
So we're looking at end behaviors. It's the right side is pointing up. If it's like, okay, so you said if it's even, both of them are pointing in the same direction. And then if they're odd, then we know that they're pointing in different directions, but which side is starting up? The right side?
So even or odd is the degree. If the degree is even, the two ends point in the same direction.
Direction, right.
Either up or down, right?
Mm-hmm. So that's all that the leading exponent tells us. It just tells us it's in the same direction or different direction. It doesn't tell us like which side is up and which side is down.
Right. So even could either be just based on the degree. Mm-hmm. If we're just talking about the degree of the function, we either have an even number, which tells me it's either going to go like this, both sides up, or both sides down. And then if it's an odd number, it's either going to go one side, the right side up and the left side down, or the left side up and the right side down, correct?
Mm-hmm.
Those are our options. Now, to determine the next part, you look at the leading coefficient. Both sides will be up when A is positive, when A is greater than 0. The right side will point up if A is greater than 0. So the right side is up if A is greater than 0.
Okay.
But if the A value is less than 0, the right side is down. And then depending on if you know what the right side is doing and you know that the degree is going to tell me what the other side does. Because if the right side is down and the degree is odd, then the other side has to go in the opposite direction. Whereas if the right side is down and the degree is even, then both sides go in the same direction.
Okay.
Does that make sense?
Yes, it does.
And that's all just based on standard form, degree, and leading coefficient that we can talk about in behavior. And then once we have roots, we can really sketch a graph.